Hi, I'm back again, and hopefully this is the last little video clip in topic 2.4. So I'd ask you please, when we finish this, could you please go back through the whole section and make sure your understanding is okay? And if it's not, can you let me know, and we'll go over whatever you'd like. This video will be about something called the tricellular model of circulation. So it basically explains the movement of air around the planet, and the reason we're interested in it is because that is what creates conditions for different types of biomes. So it's one of the things that affects biome distribution. It's one of the main ones, but it's not the only one. Yeah, you know that already. We'll talk about that a bit later. Let me start by looking at the syllabus as usual. As far as this part is concerned, the syllabus just says, it's one sentence. It says you need to have knowledge and understanding of the tricellular model and how it explains the distribution of rainfall and temperature, and in turn how that affects the distribution of biomes around the planet. Okay, so let's move on to these two maps. There's one above my head already. I don't know if this text is visible. I'll explain this anyway in as much detail as I think is necessary. But if you want to pause and take a look at what it says before we move on, feel free. I should point out that I'm not a physical geographer and neither are you. So we could go into an awful lot of detail with this, but I'll try and keep it as simple as possible, partly because my understanding of it is not that great either, to be honest. On this map, this is a map of the globe. I've already put the points of the compass, north, east, south, west, and across the centre we've got the equator. So what we're interested in is what happens as we move north of the equator to airflow, and what happens similarly as we move south. And this diagram basically explains it. It says that as you move above the equator to about the 30-degree point, which is just outside the tropics end at about 23 degrees north and 23 degrees south. So basically most of it is contained in the tropics. We've got a packet of airflow which is called a Hadley cell. Named after the scientist that discovered it. So we've got a Hadley cell to about 30 degrees north, and we've got a Hadley cell to about 30 degrees south. And conditions in the Hadley cells are pretty much the same. Above the Hadley cell, between about 30 degrees and 60 degrees north and the same south, you've got another cell. So it's a package of air that doesn't circulate with the ones above or below. And this packet is called the Ferrel cell. And above the Ferrel cell and below the Ferrel cell, if you're moving south, you've got the polar cells. So let me go through that again. Above the equator, you've got the Hadley cell, the Ferrel cell, and then the polar cell, and the same moving south, a Hadley cell, Ferrel cell, polar cell. Now, unless you're a flat earther, which I hope you're not at this stage, you'll realise that this is a two-dimensional diagram of something that's three-dimensional. Excuse me. So these cells, excuse me. So these cells are basically in bands across the planet. 3 bands above the equator and 3 bands below. This gives it in a bit more detail on the left of your screen. It possibly would make more sense if it was if the screen was tipped sideways. But don't tip your computer up, just use your imagination. Here in the centre you've got the equator. Let me write that in. The equator. And here you've got, this is moving north. You can just about see Canada, North America and the Arctic there. And this is Antarctica down here, so that's the south. So this is a representation of the same map. Alright, so let me try and move through it fairly quickly. At the equator you've got the most insolation, the most exposure to sunlight. It's hot and humid, and because of that insulation, the hot air rises. As the hot air rises, it causes low pressure because you're moving particles of air upwards. Low pressure leads to rain. So here, if we're talking about biomes, it's ideal conditions for tropical or equatorial rainforest. So just to the north, I hope that's readable, to the north of the equator and to the south of the equator, you've got ideal conditions for rainforest. That's the first part of the Hadley cell. So the hot air rises. As it rises, it cools, and then it falls. As it falls, that causes, because the density of the air increases, that causes high pressure. High pressure with very dry conditions, that's ideal condition for desert. And the same in the south, desert. That's not very clear. Just to the edge of where that air is falling. In between the rainforest and the desert, grassland. Same in the south. I won't write it in each time. Okay, so that explains what's happening within the Hadley cells. You're going from rainforest to grassland to desert because of this change in airflow. The air, as the air sinks, actually, it causes winds, and these are called the trade winds. They move back towards the equator. Incidentally, I'm probably going into too much detail. In the middle, because these two cells are not really circulating with each other, you've got very, very little wind, and you might have heard of this. It's called the doldrums. The doldrums, if you were a sailor, was a place to avoid because that was where there was no wind, so it could be so calm that you might end up not moving at all because of the lack of wind. So the doldrums occur right at the equator. Here you've got moves into a second cell. These two cells meet, but they don't really mix. And this is moving from, this dotted line, from the Hadley cell to the ferrule cell. So at the start of the ferrule cell, you've got this cooler air that's sinking. So you move from desert basically to conditions of high pressure again. So you've got desert again where these two cells meet. Moving further up to the other end of the ferrule cell, you've got rising air. The rising air creates, again, low pressure. Low pressure causes rainfall with condensing air. So here you've got wetter conditions, so you move from desert into temperate forest. Temperate forest, and the same in the south, temperate forest in the south. So that's the ferrule cell. And again, this meets colder air. The colder air is rising again. So that leads you from temperate forest to probably taiga and tundra. Okay. And then finally, when you get to the edge of the polar cell, the air is sinking. It's causing high pressure again, which is dry, no rainfall, and this is where you find what we call polar desert. Very dry and very cold conditions. Okay. So hopefully I've explained that in sufficient detail, or maybe too much detail. Let's finish by just looking at another map of the world, and this map shows you the distribution of biomes. Here at 0 degrees we've got the equator, 30 degrees north and 30 degrees south would represent the edges of the Hadley cells. So here we've got the Hadley north and the Hadley south. And on this map you can see the distribution of the biomes. Directly at the equator you've got equatorial rainforest. That moves from rainforest to grassland, and then at the edge of the Hadley cell into desert, which is what hopefully I said before. Above the Hadley cell and below the Hadley cell, or I should say to the north and the south, you've got the ferrule cell. Have I spelled that correctly? Ferrule cell north, hopefully, and ferrule cell south, up to about 60 degrees. And there again you go from desert into temperate forest, up to about 60 degrees. And then above 60 degrees north and below 60 degrees south, you go to the polar cells. Polar and polar. I should say polar. you go to conditions where you go from temperate forest to taiga forest to polar desert conditions. All right, hopefully that makes sense. Please, obviously, you shouldn't just assume that this is the whole reason why we get distribution of biomes. Obviously, they're not straight bands, straight lines. They're affected by the things like altitude, all the other abiotic factors that we looked at, and the biotic factors. And you've also got to consider again the effect of humans as well on the distribution of biomes. Now, hopefully that made sense. Please get back to me with any questions. The main thing is that you understand why these 3 cells south and 3 cells north cause this distribution of biomes, and you need to remember those distributions of biomes. Okay, I'll leave it there. Stay healthy, look after yourselves, and I'll be in touch with some work based on this stuff. Thank you very much.